Looks like the audio is decent, so we're getting started here. So in our next set of explanations, we're going to be going through and exploring the use of an additional element of the AnyLogic modeling vocabulary, namely events. And we're going to be using events to explore dynamic populations within the context of AnyLogic. So events, I had mentioned before my sort of brief overview of the elements of the AnyLogic modeling vocabulary. Events provide us a way of scheduling activities. And by adding an event explicitly, we can have certain actions fire off at certain times within our network. So we're going to be building up a model from scratch to decouple this from the last exercise. So I'd like you to close out that model that you have to minimize the chance that you confuse the two. And we're going to start once again with a blank slate. And now there's going to be a series of 30 sit-ups that you do. Okay, so tell me how to add a model. Okay, file, new model. Okay, great. This is going to be called simple open population model. Okay? Open population meaning that it's not going to be a closed it's not going to be a cohort. It's going to be a population where people come in and people leave it. Okay. Now I'd like to add an agent class. How do I do that? File, new, agent type, and it will be called person. And oldies but goodies. Well, actually, this is a situation where we won't actually need to color them in any particular color. So I'm actually quite open to alternative representations. Some of you might find it interesting to use representations from these pictures down here, such as a person or a nurse or a doctor or a patient. Others of you might find it interesting to note that if you do new agent type, and if you were to do person test or something, you do next, you can actually pick a representation visually of how you want to represent them. So some of you may even want to do something like that. I'll drag in a person here, as indicated by this representation. There's all sorts of visual representations you can use together with AnyLogic. Just bear in mind that the simple geometric representations are often easier to color in a custom way because they have fewer pieces to them. So like for this person, we might be able to color his head separately than his body, but it's hard to say like make the entire color red or something like that. And so it's not quite as quick to kind of set their coloration to be in a very uniform way. Okay, so I've just added this thing from the pictures area down here, and that's good. And how am I going to add a population of people? Riddle me that. Okay, go to Maine, and what do I have to do? Drag. Good. Okay, and I'm going to name it population. What else do I have to do? Okay, so we have to set it to population of agents, initial number of agents, 100. Suppose we want the population size to be determined via parameter, so we could easily change it. What do we have to do? Add a parameter to Maine. Good. So add a parameter to Maine called population size. You're up to about sit-up number 15. Okay, so population size. What sort of type is population size? Is it a double? Is it a color? Is it a person? What is population size? It's integer. Thank you. let's give it a default value of 100. How do we make that the population size? That was set up 16. How do we make it the default population size? This is set up 17. We're in a boot camp. Okay, how do we make that the default population size? Population size, that's right. Population size, okay? Okay, so we made it the population size. That's great. Okay, we want to, will this model run right now? Well, it'll be interesting to look at if it runs. Why not? What do we need to make the people have? Yeah, let's lay them out in a random way. Okay, setup number 17. Where do we go to set them to have a random location? Maine, good. Okay, and where in Maine? In Bangor or Bathurst? Okay, layout type random. That's right. Okay, layout type random. Okay, should we run it? Let's run it. Okay, we should see something like that. Depending on your representation. I have a feeling some of you have been experimenting with alternative representations of people. Fair enough. So we have people scattered over the landscape here. That's good. Okay, great. So we've been operating with populations. We've seen populations from early on which are heterogeneous, which have people with different characteristics yesterday. This morning we added state charts to capture their evolution over time. Early this afternoon we added interaction between individuals as captured through a network and sending messages to one another, person to person, and the environment to a person in the form of that force infection message. But in all those cases, in all of them from the very first, we had a fixed population size. And now we're going to transcend that limit. We're going to go to a population size which is being modified over time, okay? Okay, the first thing I want to do along these lines is we're going to try something we've done before, but with a slight variation so that people will disappear. We're going to have it so that when we click on someone, they disappear, okay? And we're going to see how that works. Okay, ladies and gentlemen, this is setup number 18. Where do we go so that we can handle clicks? If we want it, so if we click on someone, it does something. Where do we go in this model? Where do we go? So if we want to be able to click on someone and have it do something. Where do we go? Person, okay. Okay, and you can go up here. Oh, and this is the fly in the ointment for the nice representations. I'm not sure that these are going to support on click. We'll test. On click, yes, it does. Here we go. Okay, it supports on click. Okay, we're in good shape. Okay, folks. So when we click on them, we want to have it so that person is removed from the population. Okay? They can be removed from the population when you click on them. So let's click. So we're in person. How do I say remove you from the population? Well, you actually don't know that. We have to ask, who's responsible for the population, folks? Is it person that's responsible for the population? Is the experiment? No, it's Maine. So we actually could say Maine. There's actually a thing called Maine in each person that describes, you could see it here, it says Maine. It's sort of referring you to Maine. And we can say Maine, underbar remove, underbar population. And then you have to tell it who to remove. Who should we remove from here? When we click on them, who should we remove? The person we clicked on, right? And how do we say the person, the current person? It's the person handling this, the person that's been clicked on. So in some cases, it might be item, and in this case, in the case of Java, to say sort of the current object that's handling this, it's this, okay? Sort of me. It's saying remove me from the population. Okay? Now, do I need a semicolon or not? Need. Yes, I do need it because I'm telling it do something. I'm not telling it to compute a value, 4 plus 5 or log of the income or something like that. I'm actually telling it to do something. It's a statement, as we say. And so, just like a sentence ends with a punctuation mark in English, we have to end this statement with a semicolon. Okay? So here we're running the model. Okay, who needs help? I should have shown that more closely. I'm sorry, folks. I sprung forward in enthusiasm, and I forgot that others are seeing this the first time. So let me go back and go take a look at what I inserted. It's down in this thing, down in the advanced area, and it's in this on click here, and I'll put it up on the big screen. Okay? Oh. There we go. Come on. Hey, where's the big screen? There we are. Boom. Okay. I'll see if I could set it to be a bigger font. There we go. Maine.remove underbar population of this. Okay? Yeah. Question? Sorry? Okay, sure. Okay.
It's exactly the same when I get this error. Maine cannot be resolved.
Okay. Looks to me like you inserted that. So could you show me where you set that?
Sorry.
Yeah, you have to do it in person. Yeah. Okay, folks. Just as a pointer, this is something that some of you may have wondered about, and it's something it's easy to get confused about. In Maine, if you look in Maine, it has a representation that's drawn from person. Here's person. Here's person, and whatever. Come on. Here's person, and whatever's in person is shown in Maine. Here, this is actually showing the coordinate system where those people will be displayed, sort of what relative to what point they'll be displayed. So the space associated with this population. You notice this, folks? This is important. As I change this location, these numbers down here change. In other words, where this population is shown from is changed by this location. If I drag it out here, the X location goes up. If I change it back to here, it'll be at 0. So this is just showing the place where the population will be shown from in greater values of X, greater values of Y. Well, and this defines sort of the origin with respect to the locations X and Y of people. And it's very easy to confuse that with this representation. So it's easy to think, oh, I'm in person, where really I'm in Maine. So it's easy to go and try to associate things with this, like on click, when really we're trying to associate them with a particular person. Okay, is that helpful? Okay. Okay, ladies and gentlemen. So let's go run this thing. Okay, and now let's click on a person. You notice they disappear? Do you see that? Okay. Do people see that? Who needs TA help? Who needs professor help? Okay. Okay, folks. So we've been clicking on people. We've been deleting them. What would happen if they're in a network? Let's go put them in a network. How do I put them in a network? This is setup 19. How do I put them in a network? Okay, it's in Maine. And where do we go in Maine? We go down here. We go to network type, and we'll impose a distance-based network with a connection range of 75. Okay. We're going to set a distance-based network with a population with a distance of 75, a distance threshold. What does that mean, 75? Who can tell me that? What does that mean, connection range 75? Can anyone unpack that for me? Good. To each other. So if person A and person B lie within 75 units of distance of one another, they'll be connected, otherwise not. Okay? Okay, so let's run this now. And now we'll see people associated with network. Oh, no, we won't. Why don't we see them associated with the network? Connections. Yes, connections. This is setup number 19, and I'm going to do this one with you because evidently my abs need strengthening. Okay, so now I'm going to run this, and there we go. Okay, now let's delete someone. Let's say this one. Boom. 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 What we did is we went to person, and we went to their connections, and we scrolled down to draw a line between agents. Yeah. Okay. But do you see what happened there? Watch this. Click, click, click. Do you see what the problem is? Yeah, the connections are not being updated. So let's go change that. Let's go to person, and in addition to handling it when we click on it by removing them, let's also get it to recalculate the network. Okay? So we'll say apply network. Okay? Okay, so now let's run this, and now let's do this. Okay, so now they're being deleted from there when we apply the network. So how did I do that, ladies and gentlemen? I should have shown you for longer. It's under advanced, okay, and this is the code on the on-click. So after remove population, I have this, apply network, okay? And what this is saying is, hey, Maine, go recompute your network. Does that make sense? Saying recompute what your network is, and it will sort of wake up and compute the network, okay? Are people comfortable with that? Okay.
Could you go back there where you just worked?
Sure. To this thing? Sure. Okay. The on-click has, this is what's in it here, but I'll be glad to show it to you. So, sorry, unclick is in person. What am I doing? Okay. And here we go. Okay, there we go. Apply network. Okay. Okay, that's great. So we've removed them now from the population. I'd like you to confirm that the population size is in fact changing. Okay. Okay, so let's run that. So I'd like you to take a look at the population size, and when I click someone, you notice the population size is changing there? Do you see that? Yeah? Right? 96, 95, 94, okay? Okay, so we've just removed someone from the population. Let's now go and make it so that we can add people into the population, okay? Now, there's a bunch of different ways we could do this. We're first going to do it by actually doing something rather different. This is going to be a skill you're going to be applying over the next several days, but it's the first time we will have applied this. We're going to actually add into this model a little button. We're going to push, and it will add someone to the population. So if you go down from the top here, there should be something called controls. And you can drag in a button here. Okay? It's down here, controls. You can drag in a button. And this will be called button add population, or let's call it add population button. Okay? And we'll say this, or sorry, add person button. And the label will be add a person. Okay? Add a person to the population. And what we're going to do is we're going to undertake an action. When we push this button, something will happen. Okay? Now, where is this button located? It's in Maine. We don't want every agent to have a button, although we could do that. We want the population to have a button. So how are we going to add this person to the population? How do we remove them from the population? We did remove underbar. We did this thing, right? So how are we going to add them? We do add underbar population, okay? Now, let's try that. Let's try running it. And let's try adding a button here, okay? You notice that the number of people in the population is increasing. Do you see that? Over there to the left-hand side. Oops. To the left-hand side, the number of people in the population is increasing over here. Well, it's putting them up there in the corner. It's not applying the layout. So we need to apply the layout first. So let's go put them there. We have to now apply the layout. So we should really do this add population because we're Maine and it's asking ourselves to add population. This dot, it's a little bit pedantic perhaps, but sometimes it's helpful for students to understand it. This dot apply layout. Okay. Okay, now let's see that. So these are what I'm putting in here. This dot add population, this dot apply layout. So in person, they had to ask Maine, hey, remove the person from the population. Hey, apply the network. Here, it's ourselves that's doing this. So we say this dot add population, this dot apply layout. Okay? And this will add the person to the population and apply the layout associated with them. Okay? Are people comfortable with that? Yeah. Sure. Let me just put this into place. I'll run it and then we'll okay. Oh, look at that. Oh my gosh. Okay, that's exciting. Okay. Sorry, I may have done something wrong here. Okay, this is a distance-based network. It's a layout. Oh, it's a random. Okay, yeah. Okay, that's interesting. Okay, so I guess it's randomizing them, but it's not setting the network. Okay. This is interesting. I actually haven't seen that behavior before. Well, I didn't see that at UCLA. It's beyond me. Okay. So I'm going to reformulate a strategy based on this. This is an AnyLogic 7 difference, and we're going to be able to deal with this, but I need to think a little bit. Okay. So give me a sec, and we will change this. So what we're going to do is we're going to use a user-defined layout, and we're going to set their locations to be determined from the population. There we go. At the specified point, and it's going to be uniform from 500 and uniform from 500. Wow, that's an interesting difference. Okay, there we go. There we go. Happy. Okay. Okay. Folks, it looks like AnyLogic 7 changed the semantics of that. So I'm going to ask you to do a different strategy for this. So in Maine, I'm going to go down and we're going to do the layout type to be user-defined rather than random. Okay? User-defined. And if it's a user-defined, this is going to be setup number 20, which I've just done before you. Setup number 20 is if we define a user-defined layout type, where will we specify the X and Y locations? Where do we find X and Y locations? If we use a layout type user-defined, we did it once before. Remember setting people's location by income? It was in the population, actually. In the population, we set it according to the X location. So you say initial location in the specified point, X, Y, Z. Right? I guess I should say X, Y, Z here. X, Y. So we'll just specify X and Y. This will be uniform from 0 to 500 and uniform from 0 to 500. Okay. Yeah. And that will then allow it. So let me try that again. So with the population, we're going to set their specified point. So Priyasri, could you note this? Okay, to require remedying. We need to investigate why this didn't happen in previous cases. This exercise. Okay. 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 I'd like to take a look at that. Yeah. Yeah. Okay. So for the population, we place the agent at the specified point, uniform. Okay. Here and uniform from 0 to 500 and uniform from 0 to 500. So that's going to be where we place people. Rather than telling AnyLogic to lay them out for us, we're going to tell them to lay it out. And then when we add a person to the population, they're going to come in. But they're still not in the networks. Why not? What do we have to do? Apply network. Yeah, exactly. So here we have to go this, and it should be apply network. Apply layout doesn't do anything here. So now we have this associated with that button. Add population, apply layout, apply network. We actually don't need the apply layout because we've told it to be user-defined. We'll just do it. Thanks very much. Yeah. Right. You need to describe it. Yeah, down in the description. Down here. You could say, so at the very bottom of this, here, sorry. No, applying the layout is not required because the population, rather than Maine, is responsible for dictating the X and Y locations. Does that make sense? Yeah. You can, but she was asking, I think, if AnyLogic has built-in. Oh, I see. Yeah, for Java comment, you could just do this. Yep, or you can do this if you want to do multiple lines. But yeah. But there's also an AnyLogic sort of metadata thing to save data within AnyLogic about sort of why you've done things a certain way. But yeah, if you have code, you can just use that. Okay, so we can run this, and now we're adding them in, and now they're woven into the network like that. Okay. Okay. So we're adding people in, and then we can click on them, and they can be deleted from the network, right? If we want to. Okay, that's good. So now, ladies and gentlemen, I'd like to do this in a more regularized way. We've done it through user interfaces. I'd like to switch so this is done automatically, so we don't have to click on people. It'll be done instead as part of the routine operation of this model. Okay, I'm going